Good morning, ladies and gentlemen. Welcome to the second day of the Free Software Conference here at Neutech Park. I would like to welcome you to the track of open data and open hardware. And this morning we will hear 10 amazing contributions to this topic. And with this, I would like to announce our first speakers, and they are Mariana Datri and Enrico Zanardo from the company Bees, and they will tell us how blockchain technologies can incorporate AI solutions. Please, for your presentation.
Everyone. Hi, good morning, everyone.
My name is Mariana Datri. I'm the Business Development Manager and for Bees SRL, and this is my colleague.
I am Enrico Zanardo, and a researcher at Bees, and we are glad to be here today. Thank you.
So today we'll dive into the topic of integrating blockchain and AI for a more secure and efficient open data ecosystem. We've heard a lot about open data and AI through the years, and especially already yesterday. So we know that it's a very hot topic, and today we'll integrate blockchain, who has been kind of like a bit under the radar for a bit, but it's coming back up. In a world where data is increasingly becoming an important task to manage, we know there has been a surge in the data production, and from a recent article in Wired magazine, we know that there's going to be a surge going from 79 global zettabytes of data produced in 2021 to 181 zettabytes expected in 2025. The amount of zettabytes of data is even hard to comprehend, and to think that basically 80% of all this data is still kept in a centralized storage system should give us pause and understand what that means, and like if this should be the case and it should go this way. So with these premises of this huge amount of data, and we understand that creating a healthy and thriving data ecosystem in which all the stakeholders can involved in producing, managing, storing, and consuming the data can get what they want when they want it. Is extremely crucial. So what do we need for a thriving open data ecosystem? So we're talking about data availability, which means ensuring that all the data that is available is accurate and that everybody has access to it. We'll need quality of this data. So like finding a ways to guarantee that this data is actually of good quality and in a format that everybody can read and use. Accessibility, so develop some scalable platforms and user-friendly platforms that also will allow everybody to interact with the same data. And reinforcing the concept of community. For an open data, like everybody within the community needs to share the principle of wanting to share this data and understand how to use it, and therefore want to share it and collaborate. And especially being up to date with all the technologies that are developing through the years. And like in this particular case, AI and blockchain are going to be definitely some important. But at the same time, where do we find the most challenge? The challenges for the open data ecosystem are specifically about privacy and security. Like not many people are willing to necessarily share their private information and data. So in an open ecosystem where they don't know who will keep their data, where is the data going to be? Is it going to be monopolized? And the community, people don't know each other. So like making sure that everybody understands who they're interacting with. Is my data going to be safe and respected? And is everybody going to know where it's coming from? And again, the quality of this data And there has to be also transparency, meaning that there has to be some regulation that will help us making sure that the data will be, the data will be safe and secured in the infrastructures, which are gonna have to be able to communicate within each other's. So, given all these premises, we thought, like, what is a technology that can guarantee safety and integrity? And blockchain is one of those technologies that came to mind as a first thing. Like everybody, not everybody, probably not in this kind of context, but like many people, when we talk about blockchain, start to think mainly about cryptocurrency, so Bitcoin, Ethereum. And although blockchain is the technology behind this, powering this amazing technology, the potential that blockchain brings to a network of open data and in general free market and communication and within the tech world is much more than that. So what is a blockchain? The blockchain is a decentralized digital ledger that records all the transaction across interconnected computers. It ensures the security and integrity of this data through cryptographic hashing and consensus algorithms. So what does that mean? It means that all the information and all the data within the blockchain will be immutable. So once the data is recorded, in order to be changed, it will need to alter all the and change all the following blocks within the blockchain, which means that it's going to be written in the code, visible to everyone that are part of the ecosystem, which shows definitely transparency, because all the network participants, everybody within the blockchain system, have a visibility within the connection of the blocks, and all the transactions are written and clarified who made them, when, and why. And everybody within the blockchain has to confirm and approve that specific transactions. And within the transaction, they're like these applications, these contracts, they're all self-executing, and the agreements don't need to be separately specified with a contract or anything, because everything is already written in the code during the transaction. Now, what is artificial intelligence? I'm sure everyone here already has a pretty good sense of what that means, but for a mere definition standpoint, AI refers to basically a computer system designed to mimic the human intelligence, and so learning from experiences and recognizing the patterns, and therefore making decisions according to those mistakes or learnings that have happened. So what does it bring? Machine learning detects the patterns and learns from the data that has received, and the data analytics allows basically larger models, something that humans might have harder time doing, like very large amount of data can be processed faster. And the the automation of all the repetitive procedures make the process much faster, and which allows this data to be analyzed at a much faster speed than a human or some machines could actually do without the training. And the predictive capabilities of the AI allow basically the machine, the calculation to be updated according to what the machine has done right or has done wrong, so learns and makes better choices for the future. So now, can we use AI and blockchain together to create something that can help improve the ecosystem for the open data and in general sharing and using data. At Bees, we think we can. So we created a decentralized and distributed network designed to change and promote collaboration between peers because the participant of the networks rely and can trust the networks and is the visibility of all the transaction allows the users to feel safe, and there is no central authority who is watching and managing and deciding which data is going where, but everybody can do that. And through the AI solution, we're basically finding a way to turn the data they were inputting into the network into knowledge. So then we can use the data that we've collected to make new data valuable to us and to the ecosystem and bring it back in the open data ecosystem. So how does the Bees network works? We have the base it's based on three, for now, based on three main types of nodes. We have the seed node, which is your typical node within a blockchain that keeps the distributed ledger. And then the storage nodes, which split the information, the data into chunks, and then distribute it in an encrypts them and distribute it within the networks. And then what's priority to our solution is the smart nodes that have the capability of training the models through also the data builder, processing this data and allowing the nodes and everybody to create index, GPT index, which will produce data that we can interrogate and get feedback from the information that we put in. Now, my colleague will give you a quick example of what we've been doing to prove our concept.
Okay. I'm not here just to move the slides back and forward, right? But just to represent you the final and the conclusion probably of our presentation today. This is a use case that we have already implemented, and as a collaboration with Sogei, that is a big company in Italy that is checking all your fiscal codes, right? And we are having let's say, a project that is trying to track the use of plastic bottles. Means we want to know from the production of the plastic bottles what happens to those bottles at the end. And the end is not just when you throw on the bin the plastic bottle, but probably we want to know also what happens next. Is our, let's say, way or we think that we are in line to be responsible for the objects that are based on plastic, and our end is just throw in the right bin the things that could be recycled, means like plastic on plastic and paper on the paper bin and so far and so on. We think not. It could be something else. And the else is like the integration of IoT systems. This is a particular case where we have a special bin that at the beginning was called like a smart bin, but it's not smart because it's just taking data and sending data, and we have replaced like Mr. Bean, that is not like the person, like a very dummy person that is doing a lot of movies, dummy movies. The Mr. Bean is able to process data and analyze which is the producer of that data. Is like Lete, is like, I don't know, Plose, is which kind of type of bottle is put in there, is sending the information. And we know exactly from the production how many bottles were produced and how many bottles was taken back from the users. where the bottle was bought and where the bottle was thrown out. We can also understand and knows what was happening next. Is that bottle used to generate energy, was burned? Is that bottle used again to produce another bottle? Or is like this bottle upgraded, means is becoming something better, a bag or like a suit, could be something that is changing, means could be this bottle could have another life. And then we are able to trace this process from the beginning after, let's say, after the end, right? And this is connecting IoT systems with AI or machine learning algorithms that are capable to catalog or to classify the bottles and also be able to generate a sort of rewarding. This is the reason why we are using like blockchain as a glue to connect and be able to send tokens, let's say, to reward users based on their own way to use the system, right? And actually, this is our use case. And probably we have a lot of others that are coming into account right now. And I think that is the end, right?
Yeah, so basically this is going to create a way to create also accountability, because now you're seeing, actually, it's not just saying the company telling you they are recycling, but now each company could be responsible for their amount of plastic put out in the world, and to make sure that they know where it's going and when it's coming back to the recycling process and all that. And yeah, so we basically, hopefully with bees, we'll be able to utilize, because that's where we're moving for data analysis with all this parallel computing, free software, and all the IoT devices. We're hopefully gonna move towards a future in which data are not overwhelming us, but we're gonna be able to manage them. Sorry. Yeah,
Close
sorry.
in time. Thank you to our speakers for your contributions. Unfortunately, we had no time for questions, but I think in the upcoming time we can do that. So we will meet again in 5 minutes for our next contribution. Thank you. So, welcome back here at the track of open hardware and open data. In this morning, I forgot to introduce myself, so I will do this now. My name is Johannes Brunner. I'm responsible for automotive automation here at Neutech, and it's an honor to me to follow you in this session. Our next speaker is Martin Rabanza. I invite to the stage from the company R&B Consulting, and he will tell us about real-time airplane tracking. Please.
Thank you, Johannes. Good morning, everybody. So today we are talking about real-time airplane tracking on the Open Data Hub. And so thank you, Johannes. You introduced myself. I'm also involved in the Open Data Hub project, so therefore I will speak about it a bit. So let's start with a fictive scenario. Let's imagine we have a startup and we create a new sensor or something collecting data, and we have great data we are collecting, and therefore we want to share this data. We want to create a product out of it, or whatever our business model is. So therefore we have to share this data. And if we share this data, we have to use a platform for it. So for partners or for our own application or whatever. So therefore, distributing the data, we need some base infrastructure. And this base infrastructure generally is done via AWS or Azure, Google Cloud, or one of those many services. So whilst in our startup, we obviously don't have all these departments, but in the beginning, in the first phase, with the first leads there, we have sales obviously says, okay, there is some interest there. The development says prototype is ready, and accounting is say, okay, we have the funding. Next phase is we have some pilot customers, and the systems are running, and so everything is according to the plan. And then some more interest is generated, and the development says, okay, so let's scale up. And this is very easy with the new infrastructures or with the infrastructure cloud services we know. It's going to be interesting when there is more interest in the product, because we have to scale up, and then development is just scaling up without scaling or whatever, and accounting, so the costs are impacting more and more. So what can possibly go wrong on our product? Well, a lot of things. Obviously, cost is a main factor. So you probably all know, or some of you were already scared of what AWS generates on the cost level. Then obviously we have to deal with our own bugs and with our own software errors we make. When we share a web service, obviously this web service has to run, and customers depend on it, so they need this 24/7 running probably. And the best thing it can happen is that the customer calls you on the day you don't have time or whatever 7 times. So the customers in general, they are quicker than any monitoring you can set up, because they know exactly when the system goes down and, hey, there is something wrong. Yeah, thank you. So this is something we have to deal with, and obviously we have to be prepared for it. So, and before you know it, you are doing a 24/7, offering a 24/7 SLA, because they have your direct number, and but they don't pay you. So you don't have a contract, but they call you whenever something goes wrong, and you're just dealing with this kind of imaginary SLA. So there must be a cloud service solving all this, right? Cloud service, there are cloud services. You all know those landscapes with all the services we hear on, and they are growing like the mushrooms. And obviously you have to understand what is right for you, and don't make wrong choices, because I want to say you're trapped in there, but it's kind of like, I make the example of AWS. When you use those services, they obviously try to keep you there. So in a certain kind, they are great, but you have to know exactly what they're about, and you have to do a comparison, and that's a lot of work. So let's present another service, obviously. Now, the point is, what about the Open Data Hub? The Open Data Hub is based here in the Neutech Park. This is obviously one other service, but it's something not so far away than all the cloud services we know or we can get. And there is a team of experts here. They are they created the Open Data Hub. It's running for about 10 years now. So the Open Data Hub is something physically in a certain kind of sense. And the Neue Tech Park is here for the companies, so it's worth have a look on what the Open Data Hub does. And there are already more than 144 data sets in there, so there's a lot of data in there, and more than 70 companies consuming all this data and doing their product out of it and so on. The Open Data Hub has a data browser, has an analytics tool, and everything is free open source software, is based on open data and open standards. So this is the very three pillars of the Open Data Hub, and much more, obviously. But the nice thing is there's a great offer for data providers, and if you generate data, it's nice to have something for you, because in that case, you are a data provider. So what does the Open Data Hub offer for data providers? Obviously, it's visibility of your data. Especially if you're small, you don't have a marketing department or whatever, so you share the data with the Open Data Hub, and this gives you visibility. Next thing is visibility, not just on your data, but also as data provider, as you as a company. The best thing probably is the advanced infrastructure behind it, because the Open Data Hub is a very, very stable and complex let's say, cloud service, or based on cloud services, but there is a team behind, so it's running, so you don't have to take care yourself of this infrastructure. There is documentation, so normally it's when you write some services, documentation is always something you have to do, so it's more work, and the Open Data Hub has a documentation that has professional documentation writers. There's Web Component Store, where you can, together with the Tech Park, you can create demo applications for your data or your use case. And there are a couple of other things, like prepared mailing list for communication, statistical overview. The next thing is a ticket queue, so there is a customer care. Whenever there is something wrong, there's a customer care taking care of when customers write a ticket. So it's not like the phone calls early in the morning when customers see, there's some hiccup. And of course, error monitoring and escalation, it's all part of the deal. And in the future, the Open Data Hub will provide also the possibility to easily join data spaces. This is the new buzzword on a European level, but it's these data spaces where you can join, you broker your data with other data spaces in other countries and other regions. So, well, I wrote OAAS, it's probably not the best name, Open Data Hub as a Service, but anyways, there are a lot of companies already providing data to the Open Data Hub, and this is just some logos from them. Behind the scenes, the Open Data Hub is, as said, pretty complex. So the services the Open Data Hub is offering. So there is obviously the inbound side, where we have the data provider. So this is your location where your data is going into the Open Data Hub. It depends then on in which level. And the Open Data Hub stores everything. So this is the integrator where everything goes to the raw data tables, and after it, there are the transformators transforming your data and putting them to the data mart in the specific domains or data spaces. And then there is a whole bunch of outbound APIs where people then can take, people or yourself or your customers, partners can take the data as data consumers. So let's switch to a real-world example. In the case, we created a sensor network intercepting air traffic, and air traffic can be intercepted because every airplane has to send out its position, its speed, its altitude, and so on. That's by illegal. So that's a rule that depending on the airspace you are in, you have to send this with your transponder. And everybody, like Flight Radar, you probably know this application where you can track the planes on the application. And there, this is basically the same technology. So since this is sent over the air, you can just collect this data and understand where it is and process the data. And so you can basically create your own Flight Radar. So, and there, therefore, you have to pre-process the data and then send it to some system. In that case, it's the Open Data Hub, and send to the inbound MQTT. And there, number 5 and number 6, this is the fast lane, because if you are having this many data, because they are sending kind of couple times in a second, you're getting a position, and since they are moving quite fast, you don't have to, you cannot deal with the delay, otherwise it wouldn't be real time. So in the Open Data Hub, there is the possibility to activate the fast lane where the data is published immediately to the outbound, and there you can integrate everything with a WebSocket in your application, so you see the plane in real time. When you look up, you see, okay, that's the right position. Obviously, when the data should be stored, a transformer is post-processing the data and then store it in the data mart or whatever for later analysis, and then shared via outbound REST API, because REST obviously is not the right thing for real-time data. REST is more than, okay, show me the track of this aircraft or whatever. So this is just a picture on the intercepted ADSB traffic, where we see one Lufthansa flag, that's the yellow one, and a military helicopter. So that's the Lufthansa with the call sign here, and it's the military helicopter here. And we see that the Lufthansa was descending on a lower rate here, and so on. And this is happening all in 34. This is more or less in 10 seconds. So, all right. So the components architecture looks like this. On one hand, we have this real data that also the towers are using. So they are receiving basically the same information, and you can receive this data, send it to the MQTT broker in the Open Data Hub. There's an Apache Camel, so we are not going too much into detail on this stuff. How it works internally, but anyways, it's then stored in Postgres and then via REST API. Obviously, in this picture, there is no fast lane here, and in the end, you have the live air traffic map where you can see in real time where the aircrafts are. So behind the scenes, it looks like you see that the blue one is like the path the flight data is taking through the Open Data Hub, and here you see that we have on this side here, the flight data going into the MQTT integrator, then storing data in the raw data tables, but this line is here the fast lane where we just go directly to the outbound and to the flight data consumer. So wrap up, the Open Data Hub can be a great alternative to many cloud services that you probably can create your own infrastructure by yourself, but I think it's worth to think about the Open Data Hub. It has a very, very powerful infrastructure, so no problems on latency or server capacity. And there are already a lot of other data sets and data processing or processes there that might be of interest, that could be refactored or could be useful to your data as well. It can be used both for open data and for closed data. So obviously for a feed-in, this is something to be discussed then with the Open Data Hub team. But anyways, if you are creating your startup or your service, you can understand or you can apply for restricted data and say, okay, I have to test this, and once I'm ready, I'm publishing my data then as open. Everything is full transparent, 100% free open source software, and you can contribute also to the development. Here are some links, and that's basically it. Thank you very much.
Thank you, Martin, for your contribution. Are there any questions from the audience? Man was first.
Hi, thank you. You said that the Open Data Hub is usable for closed data. If my application now produces personalized data that I would like to use operatively because of searching algorithms that the Open Data Hub provides or something, can I, like, if I continue paying the fee, I can use it indefinitely, correct?
That's probably one of the scenarios. This had to be discussed with the Open Data Hub team, but if you want to use it for keeping it closed, it's a use case, yeah.
Thank you.
So very short. Okay, we can do it in the break, and you can directly ask Martin. So thank you again for your contribution, and we will be back in 5 minutes for the next speaker. Welcome again to the Open Data and Open Hardware track of the SFSCon 23. Our next speaker I want to invite to the stage is Elena Meines from EURAC Research, and he will tell us how in EURAC the pipeline looks like for the preparation of weather data. Please, Elena.
Good morning, everybody. My name is Elena Meines again. I'm a meteorologist, and I'm a junior researcher at the Center on Climate Change and Transformation. And today I will present a pipeline for gathering and monitoring multi-source spatially interpolated meteorological parameters in near real time. This is the result of the collaboration with some colleagues of mine. And why do we want to gather and monitor meteorological data? Because weather impacts our society significantly, especially with extreme events, for example, heat waves and heavy rainfall. And updated and high-quality meteorological data are essential for monitoring and mitigating these events, and also for understanding how these are changing in our warming climate. So what are meteorological data? These are variables such as precipitation, air temperature, wind speed, and these are recorded by weather stations that operate continuously. This is the network of meteorological data meteorological stations that we have in our region, Trentino South Tyrol, and this is an example of a weather station that is at the Lake Tolville in Trentino. So since meteorological data are continuously produced by weather stations, we want to update the time series with the most recent values, and also we want to produce gridded data sets that can be used as input for example, impact models in our region. And also we want to make these products available to other scientists, so we upload these products, the time series and the gridded data sets, to internal and also open web archives. The iterative procedure of data extraction, data preparation, and loading is really time-consuming. So we wanted to develop a pipeline for making this procedure automatic. And also, this solution would improve the safety and accuracy of data preparation, as it would reduce the risks that are associated with the manual handling of data. So for the implementation, we use GitLab CI/CD pipeline, we Dockerized jobs runners. We created the core of the pipeline through our modules. We integrated test suites. We use the RAMV library for reproducible environment, and we also created bash scripts, especially for data extraction, but also as wrappers. So now I will go shortly on each of the 6 steps of the pipeline, in particular for making you understand better what are our needs and how we met them in the implementation. So let's start with data extraction. We gather meteorological data from several data providers that are the province of Trento, the province of Bolzano, but also weather agencies that are beyond our regional boundaries. For 2 data providers, we need to give a formal request for downloading the data, but fortunately, we have for 4 providers, the data are open and we can access them through non-open API. So we can download the new data automatically by selecting the stations, the time interval, and also the parameters we want to download. And in particular, for now, we implemented the pipeline for downloading daily data of air temperature and minimum for precipitation and minimum and maximum temperature. So then we perform sanity checks on the data that we have just downloaded. For example, we ensure that minimum temperature never exceeds maximum temperature, and also we remove the uncertain values that were flagged by the data providers. In this step, we also harmonize the structure and the format of data, and as an additional step, we compute the daily mean temperature from the minimum and maximum temperature values. Then we want to integrate the most recent values in our historical data set, and we simply incorporate the most recent values at the end of the historical time series. This is actually not straightforward because some providers supply the most recent values as provisional values that are later validated. So in the integration process, we include both validated and provisional values, but each time we perform the integration process, we want to replace the provisional values with the corresponding validated ones. Then meteorological time series, of course, have missing values because, for example, malfunctioning of sensors. So we perform a gap filling on isolated gaps with a methodology that is based on available values at the surrounding stations. And so we compare the complete time series of these surrounding stations, and we select the stations that are most correlated with the one that we want to fill. Yeah, so at the end, the missing value is estimated as the weighted average of rescaled values at the selected stations, and with a weight that decreases with distance. And at the end of this gap filling, we again check for consistency that again the minimum temperature never exceeds the maximum temperature, and also we estimate the mean temperature, the missing values of mean temperature as an average of minimum and maximum temperature. Then the last step of data transformation is the interpolation of station data into a grid, and this gridded data set has a horizontal resolution of 250 meters, and these are stored as netcdf files. So the interpolation process consists of two steps, and here this is visualized for maximum temperature. First, we interpolate the 30-year average on the grid. Also, we compute the daily anomaly, that is the distance of the daily values from the 30-year average, and we again interpolate this to the grid. And finally, we add up these two computed fields to give the daily grid as absolute values. And finally, we want to make these products that are the updated time series and the gridded data sets available for the scientists, again, for other applications. And so, in particular, we upload the updated local time series to Postgres that is accessible internally, and the gridded data sets in the form of data cubes to OpenEO platform that is a platform that is open, so to everybody. So now I will briefly talk about how we made this pipeline automatic so that new data are frequently downloaded and our products are frequently updated. So we use the GitLab CI/CD pipeline. On the left, you can see the GitLab installation we have in our servers. On the right, you see a local Linux virtual machine hosting the Docker containers that are actually executing the jobs. First of all, in our source repository, we have a Makefile that helps setting up and also testing, for example. We rely on the Renv library for making the pipeline reusable. So to keep a screenshot of all the R libraries and their versions that are needed. Then we decided which was the actual workflow and registered the Docker image for running it. Also, we schedule the running of this workflow, for example, every 2 weeks, and on the scheduled time, GitLab will spawn a Docker container for each job. And as you can see, each job that is independent one to the other is automatically run in parallel by the GitLab engine. And we are particularly satisfied with the functions that GitLab CI/CD offers out of the box, when, in particular when it comes to monitoring and troubleshooting. These functions are UI-based pipeline status monitoring, jobs logs visualization, timing information, jobs manual reruns, and also the availability of API. And also the building of the pipeline YAML file is particularly made easy thanks to the pipeline editor and its graphical visualization and syntax checking. For example, here you can see the visualization for a job, for a dependency, for a stage, and also the syntax checking of the pipeline editor. So what's next? The pipeline is already working and is being tested, but some work is still to be done. So we have to finalize the implementation of the GitLab pipeline. We need to insert the last step of publishing our products. We would like to set up webhooks for reporting to Microsoft Teams channels, and to implement a monitoring dashboard with GIS-based visualization of the updated fields. So with this, I conclude, and I thank you for your attention.
Thank you, Elena, for your contributions. Other questions from the audience? The lady in the center was first.
Thank you for this very nice presentation. I would like to know if we can access this data that you are collecting and processing when you finished, and so can we have access to this data?
Yes, exactly. The idea is to make this available. I mean, the time series will be available or are available internally in our institution, and the gridded data set are open. So yes, they are accessible. But this is only for Trentino South Tyrol. I don't know if you need this data for Trentino South Tyrol.
Yes, because I'm working with the climate change.
Okay.
And it would be nice to have access to this data. Thank you very much.
Yeah, of course, you can contact us.
So there's another question here in front.
I was wondering if you are like self-hosting GitLab, or are you using a service provided by someone? And also maybe more on the technical side, how do you showed you have several tasks then running in parallel, I guess. How do you split the data each task is working on? Because I think it's a grid, so you split the workload on several tasks. So how do you split this among? Yeah,
of course, the different tasks are one after the other because they are dependent on the previous step. So the data are, for now, are hosted in our local virtual machine. And the steps that depend on the other, on the previous ones, take the data produced by the previous step, while the steps that are independent can work in parallel. And for the first, for the first question, probably you should write to Piero because I'm a meteorologist, so I don't know if, okay.
Are there other questions here?
Yeah, I just wanted to give an answer to the question because Elena and I work together. So for the question about GitLab that you asked, I'm here. Yeah, so we actually have an instance of GitLab, which is why if you see, she had to mention that we needed to run like a GitLab runner. I mean, the generally open GitLab instance, you probably can already do your CI/CD, but for this, we have this set up as an organization. So yeah, this is why we also have access to certain things. And for example, we have this platform called Alpine Drought Observatory, and we needed to also run this on like a Kubernetes server, and these functionalities we add because we had a private instance. I don't know if this answers all your question, or it does, okay.
Thank you, and you can go more into detail maybe afterwards during the break. So, thank you, Elena, for your contribution, and we will meet again in 5 minutes. Welcome again to the Open Data, Open Hardware track of SFSCon. I would like to announce our next speaker, Christian Busse of the Free Software Foundation Europe. He will speak in his talk about free software and open science. Please, Christian.
Thanks for the introduction, and good morning, everyone, also from my side. So what I will try to do over the next 10 to 12 minutes is basically build on the things from some of the previous speakers, where we heard a lot about open data, and now see, okay, what would it mean if we take open data, try to integrate that into scientific research, and with this one try to build open science. And then, of course, as I'm a volunteer for FSFE, the question is, what does free software have to do with it? Okay, so question to the audience. Who thinks that they would have a good definition of free software? Ooh. Should be more homework. Who thinks that they have a good definition of open science? Yeah, okay. So that would be pretty much the situation how I perceived it in 2019. So for free software, we have a relatively good understanding, basically based on the 4 freedoms, so that free software should give users the ability to use, study, share, and improve software. And this is something that is a definition that is well accepted in our community and has been stable for the last couple of years. Now, in 2019, if you would have talked to scientists about open science, then you would have got rather lukewarm answers. Isn't that the thing about downloading papers for free, or isn't there something about sharing research data? So we didn't have a clear definition. And most importantly, as you see, well, we're talking about journal articles and data. We're not talking about code and software. Although in the current scientific process, it's very clear that code, software written by the researchers themselves to process their data has become an integral part, and we need that to be open to the public so that we can scrutinize results, but also reuse pre-existing methods, like we have that also in the realm of experimental sciences, so that we can build new science up on that. Okay, so now luckily the situation has changed a little bit, because what we have seen nearly exactly 2 years ago is the release of the UNESCO recommendations in open science. And in this recommendation, which is around 35 pages, the UNESCO starts with a top-level definition of open science as basically all practices that make multilingual scientific knowledge openly available, accessible, and reusable. In addition, they also give a goal why one should do that, and this is basically for the, very broadly for the benefits of science and society. Now, of course, that is a goal, why we should do that, and where we want to go in the end. But UNESCO goes further on and says, okay, of course, there are pillars that we need to build open science on. And those 4 pillars is open scientific knowledge, which we'll talk about now, science infrastructure, which I'll dive in a little bit later, communications, open engagement of societal actors, mainly which do not come from the traditional scientific community, and open dialogue with other knowledge systems. Now, if we now go into the open science knowledge part, then basically in the next definition level, UNESCO splits this into 5 categories that we've already encountered in this talk and the previous one. So it says, okay, open scientific knowledge means that there is open access to scientific publications, research data and metadata, open educational resources, software and source code, and hardware, and says that those should be free in a sense that they allow access, reuse, repurpose, adaptation, and distribution free of charge. So with this, we basically have open access, open data, free software, and open hardware, which UNESCO considers to be basically very important building blocks here. If we now finally go into basically to the lowest level of definitions, into the software part, then UNESCO, well, unfortunately uses, of course, open source software, not free software as a name for that, but anyhow. They provide a definition what they consider to be open source software, and that is software whose source code is made publicly available on an open license that grants users to the right to use, access, modify, expand, study, create derivative works, and share the software as its source codes. So this is, in slightly changed words, our 4 freedoms as we know them in the community. Hallelujah. In addition, UNESCO provides an additional recommendation, which is that they say that if you provide open source code, you should also provide open data and the open specifications along with that source code, which is also, I think, another positive idea that takes up, of course, more recent software development practices, or good software development practices, because this is, of course, stuff that you can use to, of course, to build, for example, unit tests on this. Okay, so to sum up this part, which is basically now more the policy perspective on this, so the UNESCO recommendations for the first, or as one of the first really top-level definitions that we've seen in the field, defines software as a first-class output of the scientific process, which is basically on a par with open data and open scholarly communication. So basically, it's now clear that software is here to is of course here to stay. The next thing, as I mentioned, the recommendations requirements, what constitutes open source software, are directly aligned with the definitions that we already know, which means that we can basically reference to the UNESCO recommendations if we advocate for the use of free software in scientific research. So we can go to scientific researchers and say, okay, so if you do what we ask you to do, then you're also directly contributing to open science as it is defined in this recommendation. Okay, so now I would like to shift gears and come basically to another important paradigm. If you're dealing with open science a little bit, then for sure you have encountered the FAIR principles, which is something that people, because it's a little bit more tangible than open science or open science itself, is something that many people are using as a guideline, basically what we would need to create in terms of an ecosystem. And it will also appear in one of the later talks in the session. So the FAIR principles were originally published in 2016. The principles recommend that research data, in that case, should be published in a way that they are findable, accessible, interoperable, and reusable. That's where the acronym comes from. And what that means is that a data set should be findable in a way that it is part of an index / a domain-specific search engine, that it has a persistent identifier like a DOI, which is very important to avoid link rot. It needs to be accessible. That's relatively simple for us because that's usually you would resolve via DNS and then download via HTTP. Interoperable, so hopefully in a community-defined or openly defined format, and then finally reusable for people in that part of the scientific community, so that it adheres to community standards in terms of what the experimental metadata is that is provided, so that people can do scientific interpretation on that data. Okay, so now the FAIR principles is something you will find in a lot of policy documents. It's in publishers' guideline. Yes, you need to make your data fair. And it's now has reached a degree that there is even some kind of fair washing, so people just slap that label on without really understanding why these categories really exist. Now, how do we put together basically the FAIR principles with what we said before with basically FOSS? And so the important thing is, and what does that mean for free software that is generated during the research process? So what is important to realize is that FAIR and FOSS are complementary paradigms. FAIR really was originally defined for data sets, and there have been a couple of efforts to define or to spell out in very much detail what that means for code objects. Because of course you can handle code as data, but that's a transformation you better should not do. It's like treating an animal as a sausage. You lose a lot of context there. And of course also the development process for a data product is different than for that of a code product. But nevertheless, there are a couple of publications on this, so that issue is solved, I would say, 85% by now. Importantly, B in FOSS is not necessarily FAIR. If the software is not accessible, okay, you're out of luck. On the other hand, FAIR software is not necessarily FOSS, because FOSS says something about licensing, but it only says license needs to be specified. It can be a proprietary license, but because FAIR only says specified, it doesn't say anything about open. And then finally, and this is where the infrastructure now comes in, is a digital object, if you look at those criteria, cannot be fair by itself, but it needs a scientific infrastructure that it lives on, like a repository. And so this then brings me basically to my last slide. So what we've seen now is that on the policy side, top level as defined by the UNESCO document, we're pretty much good for now and probably for the next couple of years. But what we should now basically address is to build up a community-controlled and publicly funded infrastructure so that we can provide basically a space where researchers can then hopefully publish software artifacts that they produce during their research. These repositories need to provide support for a fair ecosystem. This is one of the things. Yes, you can run your own GitLab instance, for example. That's a good start. But GitLab, for example, right now doesn't yet support DOI. So with this one, you would have the open repository, but you wouldn't necessarily have the persistent identifiers, which are important in this ecosystem. And then finally, so this is then more addressing the supply side, of course, publishing software via such repositories is something that needs to be reinforced via the academic incentive schemes, because otherwise preparing the software so that it really is ready for publishing is additional work and won't happen if there is no benefit for the researchers. Okay, so that's it from my side. Thanks for your attention and happy to take questions.
Thank you, Christian Busse. Are there any questions here in the last row? Emma will come to you with the microphone.
Thank you very much. It's really nice to see the FSFE thinking about open science and open data. I've thought about this for several years working in academic research, and one thing that I've thought is one of the big obstacles for open science is the historical publication process, where all of the incentive, as you mentioned that last slide, is the final publication, and all the open science stuff comes afterwards. It's layers on top of that. Yeah. And I'm wondering if you've thought or have looked into things like the Open Science Foundation or other approaches which are trying to maybe rethink the platforms and the way that we publish in science so that the stages of the research process are more like open development. So you get transparency in the planning stage, transparency in the data collection phase, et cetera.
Okay, so very, very quickly, because we only have 1 minute left. So yes, we need to reform that process. This is something that even the EU Commission is aware of, so I think there is movement in this one. What is important, I think, for now is that we break up, as you said, right now there's only the journal publication as the last thing, and we need to provide independent publication platforms and independent credit for data products and code products, potentially also for hardware, so that the people who specialize in this can get credit for exactly this thing and are not the middle authors in an author list of 30 people. So that is important. I'm a little bit more cautious after Corona with having basically that live tracking of every type of research, because in the end, there is a prerogative of basically scientific freedom. And that means that you still, as a scientist, can choose not to publish. You should have good reasons for that, but it must be possible to do that.
Thank you, Christian Busse. I have to announce that the next speaker, Natale Vinto from Red Hat, unfortunately was cancelled due to health reasons. So we will meet again at 11 o'clock and enjoy the break and enjoy networking with each other. Thank you. Welcome again to the Open Data, Open Hardware session of the Free Software Conference. Our next speaker is already on the stage, Andrea Vianello from URAC Research Center of Sensing Solutions, and he will talk about achieve fairness, with the big letters, fair, with the EDP portal. Please, Andrea.
Thank you very much for the introduction, and good morning, everybody. So I will present you today the work that we did mainly in the last year to improve our environmental data platform. That is a platform to support the fairness of our data set, and so to help our researcher to share the data easily, following the fair data principle that were already presented before in another presentation. And so we try to implement the fundability, accessibility, interoperability, and reuse of our data set. So the topic of today is, or my topic is not the software, but how we share the data set. And why the fairness is so important for us and probably for everybody. It is because data sets are increasing a lot in volume, but also in the complexity of the data. So researcher and user in general require always an increasing support by the machine. And so fairness try to guide the user and the developer to provide the interoperability machine to machine. And the environmental data platform that we improved is the result and the way that we try to support our researcher. And if you're interested, you can just go there and have a look at our platform. So the components of our platform are 5, the main components. All of them are open source software. So our components are based by open source solution. And on top of this, we developed also our custom web portal to provide the access to the functionality that we provide. Then we have some data repositories to organize, store, and provide access to the dataset using mainly API and standard web services. We have a metadata catalog that is useful to describe the datasets and also to provide the documentation and snippet code to simplify the access to the dataset. Some web tools to visualize, process, and manage the dataset that are in our repository, and some documentation that really support the user to use the EDP, the environmental data platform, and to process the data. In the last year, we work a lot on these 3 components on the left to improve the fairness, so the interoperability machine to machine. How we can evaluate, estimate the fairness of our data set? Well, here on the right, you can see the web page of one of the metadata that we share in our platform. Exactly, this is a time series raster data that we store in the Opinio API, so in a data cube. And we used the Fuji tool, that is a web tool provided by the FAIRSphere project, and Horizon 2020 project, that provide this web tool where you can just fill the URL of your metadata, or the DOI, as we did in this example, and you get the evaluation of the score of the fairness of your data set. So as you can see, when we started 1 year ago, more or less, we had really a very low score. And why we got this very low score? Because we're thinking we have web services, we have metadata, we have everything, but the result, the final score, is just 4%. It was because our interface was designed for the human user, not for the machine user. So we tried to improve the machine-to-machine interoperability, and in the last time we reached the 87% score. So I can say a good improvement. And now we'll try to describe how we reach this result. So this is our homepage, and as you can see here, what are these DOI? They are the DOI that we got registering our repository in the FAIR sharing portal. This is an organization that tried to provide a DOI and metadata for a repository, like our Opinio API. That is the API where we store raster time series, so big data set from remote sensing or model, like the dataset that were presented before by my colleague Elena for the climate dataset. They are stored here. And then we have the Maps portal, where we store vector and simple raster datasets. We share also the metadata, and the portal is useful also to easily set up a web map to visualize the data and to query the data itself. In addition, we registered the DOI also for the environmental data platform in the total. We are still awaiting the final DOI because it takes some time, but it was approved. And the environmental data platform is of a different type. As you can see, here is a knowledge base, not a repository like the two on the left. And this means that the environmental data platform is something that provides information about the data set. And it's not just a database, but it's a collection of databases that provide additional information, like the documentation and the snippet code that we store there. Let's have a look to the metadata catalog. That is the main components to provide the fairness. The architecture is composed like this. The core of the metadata catalog is based on the GeoNetwork solution. This is useful for us to provide the catalog service for the web, that is the standard to share metadata of the OGC. And GeoNetwork harvests automatically the metadata from the API of Opinio and from the Maps portal. From the Maps portal, GeoNetwork interacted directly with the CSW standard. For Opinio, instead, we set up some script to transform the format of Opinio, that is a JSON file, and we transform it in an XML file in order to be harvested by GeoNetwork easily. In addition, we have here on the right other repository like PostgreSQL databases or InfluxDB. There we store dataset like the climate database, and we create for this manually the metadata directly in GeoNetwork. I want also to tell you that some data like the climate database are also connected to the Open Data Hub of the province. So we share the climate database by our API, but also directly by the Open Data Hub of the province that is presented many times today. So no, I don't want to add anything. On top of GeoNetwork catalog, we developed our custom user interface to have a more user-friendly user interface, more simple to access and to read. And in addition to the metadata, we provide custom documentation for each record and snippet code. Snippet code means that you get a Python or R code that is ready to be connected with the dataset that you visualize on the platform. On top, in addition, really, this year we set up also a stack catalog. Maybe that you know this new spatio-temporal asset catalog specification. It was born for the Earth observation community. And my next colleague that will present, Rufai, will say something about the stack catalog. It's a new type of catalog that we set up recently. You can have a look if you are interested. It is based on JSON format, so very simple to be used by machine to machine and to find easily the link to access the dataset, so very useful. And we'll try to synchronize the GeoNetwork catalog with this stack catalog that is always more used by the research community. What are the metadata improvements that we did? We try to work a lot on the completeness of metadata, so the information that you can find to describe the dataset, and we work a lot with the signposting. This means that for each record, we added the link set and link data JSON file that is used by the machine. So the user in the user interface don't see anything, but in the header of the HTML page, there are this JSON file used by the machine. For humans, we improved a lot the information that you can visualize in the interface. So we added, for example, the digital object identifier and the citation that is really relevant for the research work, for the publication, and many other information. And we added here 2 buttons, just as an example, a test for us to visualize the JSON file. So it's not really useful for the human, it's more a test for us to verify the JSON file. But here you can see how the machine can read and get the information that are useful for the processing of the data itself, so for the interoperability. And this is the signposting. Finally, as conclusion, I just want to give you a suggestion that the effort to reach the fairness is not just in the software, in the application that you set up, but there is also a big effort in the creation of the metadata. So it's really relevant to create a complete metadata. And you really need a lot of effort also in maintaining this information always updated. Otherwise, your fairness is just, let's say, poetry, but nothing useful. So this is my conclusion. Thank you very much.
Thank you, Andrea Vianello. Are there questions from the audience to Andrea? No questions? Andrea, do you want to send another message, or did you invite someone for collaboration?
I invite people to have a look, give us some feedback about our portal. There is always space for improvement. Most of the data that we share are open data, so maybe that they are also useful for artificial intelligence testing. For example, we collaborate also with the University of Bolzano because they process a lot of data. They work with ontology, semantic, but they need data. So we share with them through the platform a lot of data sets that are useful for them for their work. So just use the data sets that are open, freely available, and if you are interested, give us some feedback so we can always improve our platform. Thank you.
Great. And question from Avram.
Thank you. Thanks for your presentation. I just have a general doubt. Do you know if there are like some, let's say, like a complementary initiative to evaluate the quality of the data set that you are sharing? Because in the end, this, as you say, like a machine to machine, there are interoperable, but who evaluates the quality? Because I can share with you data that is totally fake. And if you go to the automatic artificial intelligence methods, maybe it's not a good, let's say, like a strategy or
Yes, there are many different tools to evaluate the fairness of data. Fairness, as I said, is more sought for machine-to-machine interoperability. But there are other tools that are provided by different organizations. We just joined a workshop of the Fair Impact organization where they presented us about 10 tools to evaluate the fairness. We just decided to use the Fuji tool, but there are many others. And you can decide which one to use to evaluate your data set. Depend by your data, how they are organized. If they are stored in external repository, for example, you cannot do anything, any update on the application itself. You can only work on the metadata completeness. Instead, we had the possibility with our portal to improve what there is in the background of the application on the portal itself. So this increased a lot our score.
And I'm sure that many users, once that you share it, if there are many users, So they also will do quality testing, of course. And that's one of the nice things of open source. So let's thank again our speaker, Andrea. And we will meet again in 5 minutes for another speaker from URAC, which will speak about Python instrument. See you soon. So, good morning. Welcome again to the Open Hardware, Open Data session. I invite to come to the stage our next speaker, Rufai Omowunmi Balogun from URAC Research, and he will lift the secret, what is SmoothX. Please, Rufai.
Yeah. Thank you. Good morning, rather, everyone. I think I'll move faster in time. Today I'll be presenting to you a package that we developed in our team at the Institute for Earth Observation for understanding the evolution of soil moisture anomaly. And in this presentation, I'm going to basically walk you through what this means to understand soil moisture anomaly and why we decided to develop this tool and walk you through what SmoothX is and some of the use cases we already have and what we are looking to develop in the coming days. So first, we start from the background. If you see in this presentation, we have what seems is very common in the community of climate change understanding, where we look at the whole environmental system and we try to understand it. And since climate change has become a major topic, scientists want to study this even more in depth. And one critical way of quantifying this is what we call the global water budget, which basically quantifies the hydrological cycle, which means how water flows in the whole globe. And here we see the Food and Agricultural Organization of the United Nations has begun to show to us that there is a pressure on this, as we will also agree with different environmental crises we see. And one of the critical way of actually measuring this water budget is the soil moisture, which is, central to understanding this water budget. And now what that means is when we think of it, is when we have a column of soil on the ground useful for farmers and anybody that has to do something in this area, we look at a column of water that fills that up, and then we say this soil is moist. Basically, there is water in the soil, it's moist. There is no water in the soil, it's dry. But then, if there is water, it has it has its particular use. Without this water, it doesn't have. It also has its own use, and in this case, we see this in scenarios where we have to monitor flood and erosion, droughts, and also sustainable farming and agricultural practices. And one of the many critical parameters actually for this is also quantifying anomalies, which basically is either it's too much or too little, because these little changes can lead to a tipping point where there are all sorts of issues, and this is one of the things we measure, and we can easily quantify what are dryness and wetness condition in soil. So given all of this background of what this is, why then did we decide to develop a tool or a package for monitoring this? So first, of course, I already established to us that when we think of soil moisture and soil moisture anomaly, it's useful to be a reliable predictor as part of the hydrological cycle that I explained earlier for monitoring dryness and wetness conditions, which has multiple downstreams influence. And at the same time, when it comes to computing this using climatic data, sometimes it involves many of the times actually, it involves multiple steps from downloading, processing this data, sharing, visualization, and all of this. And this also can be very computationally demanding. And for this, we decided to develop the SmoothX, which is a package which is now available on PyPy. And what this is, it is actually an acronym for saying, hey, SmoothX, soil moisture indices, indicators. So what is it that we can use to basically understand the state at which the soil moisture is here, if it's good, if it's bad, if it's something we should be careful of pay more attention to. So this is then a tool for you to assess the data for soil moisture, to analyze it and to share it. And also when you get out a useful information, you can also share it with other scientists. And here we have it at different state of the functionalities that we have. We have a documentation for all the functions we have, which is also available as a link in this presentation. You can have a look at it if you want. And then I walk you through what this means for us to have these different functionalities. So the three main functionalities we have is first the data access, where we have a set of functions that you could use to access different APIs. Currently, the one we have developed is for accessing a climate data store developed by the European Center for Medium and Short-Range Weather Forecast. And then it has all sorts of weather parameters. And in this case, you could just set in your configuration if you want a data for a particular time, number of years, number of days at a particular hour, and for the area you want. And in that configuration, you feed into the function, and you get out your parameter. And basically, this can be scaled, like I mentioned, on a daily, weekly, or monthly basis. And at the same time, when you have this data, of course, the purpose is not just to have raw data and you don't know what to do, then how to analyze this data. And we have a set of functions also for you to be able to get proper computation out of this. And in this, you can compute climatology, different statistics that are provided. You could also compute anomalies. And for example, I show you a case where we computed an anomaly of soil moisture for September 2011 over Bolzano, basically. I mean, the reason why this data is showing this way also is because of the spatial scale. Climate data sometimes are over large area when you use this kind of data set. But overall, you see, we can see anomalies, and you see the redder it is, the more it shows us that there is too much difference. The blue it is, it shows us that, of course, these places are relatively good. And of course, in these areas where it's redder, the people working there should be careful to pay attention to the level of soil moisture and understand what happens to the agricultural system. And also, you could then take this further to see what happens to the climatology across the years. And maybe you could look at a particular year. In this case, you see, for day of year, this is also showing from 1981 to 2010, how has this parameter been changing, and you could see that on certain period of the year is higher than on other period of the year. And this is also broken down to months and seasons. And the reason why this is important, particularly for the climate community, is because most decisions of changes and in climate, or rather in weather and moisture, happens at this small interval. Within a month, you see, of course, there is changes, and then we want to make sure we make a decision to prepare within 3 months or at a sub-seasonal scale. And that is what we have. So overall, we have this tool that helps us carry out spatial resampling and temporal resampling of this climate data set on soil moisture. We can also compute climatology at different time scales, and as well as analyzing temporal trends. And lastly, one thing which my colleagues also have mentioned, Andrea and the other person who presented on force and fair, is also sharing data and publishing data to other scientists. So sometimes, which is already like a major issue in science, we publish all of these tool set or data, and it just stays there, and other scientists might not be able to access and reuse it. So STAC, which is the Spatiotemporal Asset Catalog, is a specification that has been developed as a way to easily share geospatial data in a way that is accessible. You can index it easily. So for example, if I develop a soil moisture data for 10 years, somebody might need just 1 year. And instead of recomputing it, they can basically go to my stack, look at the metadata, and pick just the 2 years they need, and won't have to reproduce this data themselves. So we also have in this tool a way for you to, whatever data for whichever region you develop, you can also create your own stack metadata out of it and put it online in a way that other people can easily access. And that's an example. And at this, we are still very much open to receiving feedback from people who want to use this tool. So we have a set of GitHub issues that you can open. Of course, if you look through this, you probably see my name everywhere because I'm the user now. But of course, we would like to also receive feedback from people to also improve this tool. And one specific use case which we have within the Institute for Earth Observation is the Alpine Drought Observatory. This is also available. You can also quickly take a look at the website where we have a set of drought indices that we serve there. And one of these indices is, of course, the soil moisture anomaly over the Alpine region, European Alps, actually. And you see, we intend to also continue to use this, our tool, to include this in the CI pipeline to make this more simpler to produce and accessible to people in the European Alps, and also in the future continue to validate this to show how effective this tool we have developed is. And this brings me to the last part of my presentation. So overall, the SMODEX is an open source Python tool that we use for assessing climate data set, in particular soil moisture anomaly, and computing these soil moisture indicators, as well as sharing the generated data set with other scientists in an open source standard compliant way. And this provides us with functionalities for spatial and temporal analysis, data resampling and sharing, and as well, this is also extensible to other Earth observation and data APIs, and for computing new indicators. And in the future, we look forward to doing all of this, to extend it to other APIs, to create a CLI tool, CLI command line interface tool, so that this is also useful in a high performance environment, and it's easier to get your output in a faster way, and of course, receive input from our users. Hopefully, we get some from this conference today. That's it. Thank you. Here are some useful links for people who want to see other things in the project. Yeah, thank you very much.
Thank you, Rufai. You have been perfectly in time. Are there any questions? You have been very clear, it seems. What is SMODEX? Some ideas for... Yes, there is a question.
Okay, thank you for your presentation. I was just wondering about how computationally intensive is this kind of computation. So you have this Python package, and if you can comment a little bit about it, if you need special resources or it's just something that runs really fast on a normal machine. Thank you.
Okay, with what we currently have, you can already do with your notebook, if you have access to this, to compute this, whatever you want. But depending on the time scale, the issue of computational resource you need is, usually when you want to compute over a longer period, then you have like 30 years, then it becomes a bit more for what you want out of it, and it becomes, you need a bit more resource. But you can already do with your CPU for now. And one of the things I think I also didn't mention is we want to include parallelization of this. So you can use, for example, you can already use your, if you have multi-core CPU, you can parallelize this instead of using just one of your core to do this computation, and then it's faster. But yeah, this is very good. I should find a way to quantify the computational intensity and see maybe the complexity, so then it's more visual to show. Yeah.
Thank you. Are there any other questions? No? Okay, then let's thank our speaker. Thank you. And so we will, and we will meet again in 7 minutes, where you will get to know why open and digital infrastructure matters. So see you then. Welcome back to our Open Data, Open Hardware session of SWESCon. Our next speaker is already here with me on stage. Welcome Charles Schulz from the FATES Xen project. And he will speak in his talk about why open digital infrastructure matters. The stage is yours.
Thank you everyone for attending this speech. Today I'm going to tell you about a topic that is a little bit, it sits a little bit in the middle between open hardware on the one hand and on the other hand, I would say open source and of course hardware diversity, ecosystem diversity and so on and so forth. So I'm just going to start right away by telling you a little bit about what we're thinking about open digital infrastructure. So open digital infrastructure really is a combination, first of all, of hardware and software. It's not just, oh, we're going to talk about the servers or we're going to talk about the server software. No, we're going to talk about the combination of those two. And in terms of architecture here, I'm not here to tell you just about cloud computing. I'm going to tell you about what the other, what the great company who no longer exists called Sun Microsystems, they used to call this the grid. They called this the grid 23 years ago. And the grid for them was, of course, what we now understand as public cloud, private cloud, any kind of data center really, but also on-premise deployments, edge computing, all the way till the IoT. And all this, if you come to think of it, might not still be the case today, but it will pretty soon, forms a continuum. That continuum, let's just call this the grid. And so it doesn't matter for today's discussion what we're going to be considering. It could be the cloud, it could be server and data centers, it could be edge servers, whatever. We're going to be talking about infrastructure. So if you're wondering what is the articulation between hardware and software when it comes to software freedom, maybe some of you know about this, but there is a little known episode that Richard Stallman describes in his book. Pretty much what got him into, not free software, but what got him into thinking about software freedom and the GPL. You remember that when he pretty much discovered the injustice or the proprietary license of software, what was really happening is that he was working at the MIT. He was, kind of an undergraduate at the MIT, and he was having an issue with a printer. Because in his laboratory, where he had those mainframe and all that, there was a printer, and he needed to print certain things, and he realized the printer wasn't just jammed, the printer had a bug. And more specifically speaking, what was happening was that in the printer firmware, there was something that was quite didn't work. So hence, the story goes on. He went to propose patches, he went to propose improvements to the proprietary printer vendor, but that company never accepted actually its patches or anything. And they were just behaving as, not a very smart way, so they pretty much were saying, well, the MIT should just buy another printer, and that's it. But he knew that you could actually fix the firmware, and things would go back to normal, and the printer could still be operating. So this is interesting, because his discovery, so to speak, of software freedom is not about the case of somebody thinking about an email client, if you will, or some sort of ERP, or no. It was about something that was very, very, very closely articulated to hardware. In fact, it was the one thing that was making the hardware, the printer, work. So already by that time, it's quite interesting to see that there is a connection between those two. The connection being, yeah, we can talk about software, but if the hardware, if you don't actually understand and manage, and if you don't have the power or some sort of mastership on the hardware, you're not going to go very far. So I just want to mention this because I think this is overlooked consideration, and we should always be thinking about hardware when we're talking about, obviously, software freedom. So obviously, software has to run on something. So we can talk about cloud, for instance, we can talk about cloud computing, but there is a quite interesting discussion. when we're basically are saying, okay, we know the motto here, there is no cloud, there is only somebody else's computer. It's true. But let's talk about those computers. The software that we are essentially using, so we're using resources, we're using SaaS, software as a service, and software as a service runs on something. It runs on another software, and that software runs on a more or less specific set of hardware. More or less because it can be elastic, of course, but at some point it runs, as the motto says, on somebody else's computer. So when we're talking about hardware, when we're talking about servers, for instance, when we're talking about cloud computing, the next question is, okay, what architecture, what processor architecture are you considering? What is your software compatible with? So of course we know we still live in a world where x86 64 dominates, sure. But this creates an uncanny amount of concentration when you come to think of it. And in fact, as you know, it's not just about x86. You're going to talk about ARM. Maybe some of you will be thinking about the Power architecture, or maybe the RISC-V architecture. Those two are obviously quite interesting with respect, not so much about the hardware freedom, I wouldn't call this, but let's say to the open access to hardware specification and the ability to take those blueprints and to create a manufacturing supply chain that would eventually come to the production of processors based on this architecture. But when it comes to x86, not so much. And in fact, we have another problem in here. I'm going to completely depart from software freedom and digital policies consideration. Here on this map, didn't make it up. This is quite the official stance. You see that we have quite a little bit of a problem. We have chip designers. We have chip designers and software development. We have integrators. We have companies who will assemble hardware. But the actual foundries, not the fabless chip designers, the actual foundries, most of them are located in Asia, into one or two countries. This obviously creates an unacceptable geopolitical risk. And more to the point, coming back to our conversation, it creates a significant threat to our digital freedom. I'm not trying to offend anybody in Taiwan, that's not what I'm saying, but at some point, you gotta ask yourself, is that healthy? Is this concentration of manufacturing healthy? So we're not the only ones here who are talking about this, because obviously we have seen several initiatives, governmental initiatives in Europe, in North America, and elsewhere, thinking and trying to untangle this situation, because this situation is a real problem. So basically, it all boils down to this. There is a reason why all of this manufacturing power has and is taking place currently in specific countries in Asia. And it's all about the economic feasibility, because in order to have an actual foundry, a CPU foundry, you need to have extensive, huge amount of capital. In fact, I was reading an article in the French newspaper the other day, and they were saying that we're now going to have near Grenoble foundry that will be jointly operated with ST Microelectronics and Global Foundries. And we're talking about a project that costs initially 7.2 billion euros. So it's not even going to be a large foundry. It's just going to be there to assumedly, provide a modicum of, let's say, maybe not sovereignty, but at least some sort of emergency supply chain, or, basic supply chain for France and to a lesser degree, Europe. And the French government had to shell out 2 billion euros just for that. It's supposed to create 1,000 jobs. Very good. I'll leave you to think about how much money per job the taxpayer has gone into this. I'm fine with that, but it costs an enormous amount of money. And of course, when you're talking about open hardware, the real question is going to be, what is our access to the specification? What is our access to the blueprint? What is our access and our legal ability to take those designs and to do something with it? And here you see how the open hardware essentially boils down to the software freedoms. to the 4 software freedoms. Can we do something with it? Can we modify it? Can we study it? Can we distribute it? But part of this, contrary to the software part, is fundamentally tied to your economic power. Because obviously you're not going to be handing out chips. Obviously you're not going to be creating a foundry with nothing and with no money. That's the big, I would say, to some extent, that's the big difference with software. And of course, once we have said that, we keep on talking about what's feasible today. We're not talking about what we're going to be doing if we had a foundry. Because having a foundry is one thing. Being able to innovate, meaning having enough brain power and enough capital to accelerate innovation based on those designs, is another. That alone is yet another completely different investment scenario, let's say. So obviously with this, we need to consider several things. Public funding, private funding, of course, public research, and private research as well. And we need to be thinking about commonalities and synergies. Obviously, there is a reason why x86 is the so common platform today, and it's not because it's the best one. We all know this. It is obviously because it managed to create network effects, and then it became essentially a maker or a platform making commonalities, making things common on the software and on the hardware level, so hardware standardization. As I said, foundries are expensive, and it ultimately brings us to something else, which is the emergence of new infrastructure players. That, too, is fundamental. We cannot have the concentration of hardware makers and OEMs that we have today. It is crucially important that we accelerate the seeding of diversity in hardware and software ecosystem. Thank you very much. Do you have any questions?
Thank you, Charles. Where are the questions? Here is the first one.
Thank you for your talk. Just a quick question. How would you propose to seed this, given that there's a restrictive legal system around hardware that actually impedes the sharing of knowledge? Talking about licenses and patents and so on and so forth. That is probably one of the advantages that Asian countries do have, where there's much more interoperability, sharing of knowledge and so on.
So I think, so that's the part I did not develop with intention, let's say, in my slides. I think that what we're seeing now is that we need to be seizing the zeitgeist. And the zeitgeist in Europe and elsewhere is to have our own foundries and to maybe not bring back some innovation home, because some of that innovation has always been in Asia, but duplicate it or kind of like in-source back certain things. But we're not going to do this, I think, with Intel architecture. We're going to be doing this with RISC-V, mostly, and we're going to be doing this to some extent with Power, but RISC-V mostly, and perhaps a little bit ARM, but ARM has its own set of intellectual property issues, let me just put it that way. If we do this, we're going to be able to have the legal background, let's say, to steer co-opetition and collaboration on a local level, basically. And then, because once you have that, you're still not entangling the oligopoly, let's say, of the hardware manufacturer. So you need to, it's going to be a slow process, but it's going to be, I think we need to think of it not as a, let's create diversity in software, but we need to be thinking as if we were to be creating a set of heavy industry players. So it's going to be a slow movement, but eventually we will be able to have this emergence of new players, I would say. At least, I work for a company called Vates, and Vates does virtualization software. We do virtualization management stack based on Xen. And okay, we do software, but ultimately because we do hypervisor type 1, we need to be thinking about what's going on on a hardware level. And yeah, sure enough, we do x86, and we're investing now massively on ARM and RISC-V and Power. But the thing is, at some point, we're seeing the moment where we're going to be having to ally with other players in Europe to actually have a continuum of hardware and software.
Thank you to our speaker, Charles Schulz. So also, even the European Commission recognized this necessity of resilience. So there is the CHIPS Act, I think, which wants to source back to Europe also semiconductor manufacturing. So we do our regular break, and we see again at 12 o'clock with the contribution for decision support systems in agriculture. So see you then. Welcome again to our Open Data, Open Hardware track. I would like to announce the next speaker and to invite him on stage. It's Giovanni Gianotta from the Noi company Group of Us. And Giovanni will speak about decision support systems in agriculture. The stage is yours.
Hello to all. So today I want to present the new idea and the new project that we are making. So we want to find some contaminants inside the olive oils, the contaminants that are defined dangerous for our health. So the MOA and MOSH stands for mineral oils, aromatics, or saturated hydrocarbonic. So they are some components. They are the oils that we use on the machine, for example, on the cars, for lubricant, and so. Why they are considered the contaminant? They are considered the contaminants. Okay. They are considered contaminants because they are not present on the original food things. So, and they can go inside from the packaging, from all stage of the production. And MOA and MOSH are present in particular in adhesive, in the packaging, and unfortunately on the recycled material. So, other part is how I introduced it, the machine and the hydraulic things, the hydraulic oils. They are used for packaging, for everything. And we use them on the lubricant. So when we take the olive, we put on our system for obtaining the oil, and they have some lubricant. So sometimes this lubricant can go inside. Actually, currently we have some Italian laws for understanding the quality of oils, for giving them the real evaluation, so like extra virgin oil or virgin oil or not edible oil. But no one measured the quantity of MOA or MOSH present inside our edible oil. These things is an important thing because European Commission, after some years, on 2022, proposed some limits. But currently there are no country that adopted these limits as a law. So the producer has a lot of problem for finding this kind of product because the analyses are expensive and take very, very long time. And for that, with CNR, we think a system that we want to create a system that uses some fingerprints from phytoclimatic and environmental condition, together some spectral analysis and optical characterization of the oil for understanding the possibility of presence of this material inside the oil that we are buying on our life. So the phytoclimatic and environmental fingerprints come from some open methods created by CNR, Informatics One, and models. Spectroscopic analysis and optical characterization, they give us the new possibilities transferred to us, the new hardware machine that they made for analyzing a little quantity of oils with laser. So, after that, all data that we will receive go on the intelligence artificial system that have the result and give to a new design support system informations for helping the farmer, the producer, and some other firm information about the possibilities of presence the MOSH inside the product. In this way, we can have possibility to make a very a vertical analysis for finding this product. Our target is to give to the firms the possibility to identify in secondary methods the presence or not the MOA and MOSH, and give them the possibilities to put a stamp MOA, MOSH-free product. The goal of the project, obviously, is an hardware and system and a software system, innovative ones, that can help to find in a fast way and economics way, so very cheaper way, the presence of MOA and MOSH inside the olive oils, edible ones in particular. So just I wanted to present this project because we are starting from next month to search all these things. So this is a first stage of, I hope, a good and nice high story of the future. So thank you and see you next year for the new and the news and I want to show the first results. Thank you.
Thank you, Giovanni, for your contribution. So that's a very nice application. We all enjoy olive oil, and so to use open data and free software, how to keep it more mesh-free, it's a good thing. So are there any questions or inputs to Giovanni? If not, I have a question. Giovanni, the laboratories for testing, do you have already there some partners in the project, or how do you select them?
Okay, the project is made from Gruppo FOS, CNR, Sant'Agata 1907. This is a product, one of the most important producer of oils in Italy, and Ingenious. Ingenious is a blockchain and cryptographic experts firm, and the laboratories will be made some on the Sant'Agata 1907 that are the users, and here in Bolzano we want to create when we have the hardware, we want to create a little laboratory for creating, for searching the MOA and MOSH for experimental things.
We are very happy to hear this. So maybe also CNR laboratories also.
Yes, CNR obviously CNR laboratories, they have some laboratories from all in Italy. The laboratories involved in our project are in Florence and in Naples. Because here they...
Yeah, and could you imagine that this laboratory, this measuring data of this the spectrographical data, could it be also open? So to, for developers, for...
so CNR is the National Research Institute. So all their research are open because they make a research for the nation. So they public everything, they show all their results Obviously, the transfer technology system provide to give us more information, but they are open. And other things, all algorithms that we want to use inside this project are open. We want to start from open AI, from open frameworks for creating all system or platform.
That is great. So we're following the FAIR guidelines as much as possible. So everybody who is practical with this kind of data, or is interested and enthusiastic of statistics, mathematics, and programming, so he could give his contribution also to get the best possible olive oil quality in future. If there are no other questions, I would say we can start with the break and see you again in it's about 9 minutes here in this room for the last 2 presentations. Thank you. Welcome again in the track of open data and open hardware. Welcome with me to stage Lucas Lasota from the Free Software Foundation Europe. In his talk, he will speak about the future of connectivity, open internet, and the human rights. The stage is yours.
Thank you. Hello, everybody. It's a great pleasure to be here, to see some familiar faces again in FSCon. And I'm very happy and pleased, and I would like to thank the FSCon organizers to open the floor for me to talk about these very interesting, important topics that had impact in our digital rights. My name is Lucas Lasota, and for those who are watching us online and are visually impaired, I'm a bald beard guy wearing a suit, and we have an auditory full of nice people here. So, yes, I would like to talk about the future of connectivity, open internet, and human rights. Perhaps this does not sound very well connected in our minds, but I would like to say that, first of all, we need to understand how we tackle the issue of control over devices, digital devices that we are using every day, because, everybody has been using devices to do basic stuff such as to work, to communicate, and etc. And how this has this corollary, this connection with our digital rights and our basic rights that, nowadays we call it human rights, and how this has the connection with the future of open internet and beyond. Right, so devices are a reality of life. We are using it for communication. We are using it for our work. We are using it, for an example, to call emergency services. And it brings us joy when we have the opportunity to explore to the maximum extent what we can do with our devices. I legitimately take this photograph and seeing these beautiful people interacting with devices there, but I would like to point out to a reality that is changing, and perhaps we need to be aware of the impact in our life. And perhaps I would like to make these questions. Do you have control over devices in the order that we can indeed use the full potential of those devices in order to enable these basic functionalities they are serving in the most critical and important aspects of our life? Perhaps this is a legitimate question that we I would like to start our presentation with this. And the realities of life is a little bit more complex and perhaps not so enthusiastic that we would like. And when we think about end-user control of devices, we start seeing there are several hurdles, especially when we talk about our smartphones and other very close devices that we use for everyday life. For an example, if we buy, and that was my case when I bought some years ago my smartphone, the first appearance of the screen that when I turned on the device was prompted me to do an online account, to create an online account in order to start using this device. So in order to exercise my rights over this device, I was prompted already to give my data to a big tech company located elsewhere. So that was a warning sign to me that perhaps I don't have the controls that I was used to have over my devices. And then when I started interacting with my smartphones, I saw that I was not able to uninstall perhaps pre-installed applications or use a different Play Store. And Play Stores nowadays are becoming more and more important because this is, the basic repositories where we can find another software for interacting with our devices. And then I come to the conclusion that I was not even allowed to change the operating system in my smartphone. So my software freedom was deeply impacted by some hurdles imposed by maybe it by the device manufacturer or by the device vendor. So And if we are using devices more and more to exercise our citizenship in the digital society, if we are using digital devices in order to access basic services in the connected society, perhaps we start having to think about the concept, the basic concept of human rights. And if we are using these tools to, as I said, to exercise our citizenship in the digital or in connected society, and we don't have control of our device, we have a big problem here. And I would like to point out to some very basic piece of legislation that has been around for a while, and the first one that was accepted by the organization of the UN is the Universal Declaration of Human Rights, and it says, everyone has the right to freedom of opinion expression. This right includes the freedom of hold opinions without interference, to seek, receive, impart information, ideas through any media or regardless of frontiers. And if we check, for an example, the net neutrality regulation, that is a very concrete regulation here in Europe, it says that end users should have the right to access and distribute information and content, use and provide application and services, and use terminal equipment of their choice. If we would only check the text of the law, perhaps I would say, yeah, my talk here is done. Thank you very much for your attention. We can go happy to our homes and we have all the rights established. But the laws sometimes are the first step for something that we have to safeguard. And if we check in 1948, this law, and in 2015, there was a law explicitly referring to devices, and we still are losing permanently in this process of losing our rights over devices. Perhaps, you know, we need to do something more about it. I would like also to quote a very recent Declaration of Rights and Principles. This is not a binding law, but are some declarations that where the European Union wants to go. And I would like to put into a highlight two principles: that the freedom of choice, people should benefit from a fair online environment and safe from illegal and harmful content. And then they talk about solidarity, talk about safety and security, and of course, sustainability. And I would like to make a point here today for us, and perhaps a conversation starter. Is it possible to achieve these principles? Is it possible to achieve these very nice ideas without end-user control of devices? What do you think? Personal idea, yeah, I would say no, yeah. But, yeah. And let's put some numbers on it, right? Let's see some numbers. And these are very concerning numbers because, well, if we take some data from 2020, we see that the digital markets for operating systems on smartphones, just raise your hand, who has a smartphone here? Except you, because I know you don't have, but yeah. Yeah, so the vast majority of our audience has a smartphone. Yeah, cool, you don't have. So we have two outsiders here. Congrats, that is really great. Yeah, but we're talking that it's a privilege nowadays. If you want, you can exercise your right to be unconnected. So yeah, that's cool. So Android and iOS have together 99% of the world of market for operating systems in smartphones, and both of them are proprietary. So users cannot exercise the four rights of free software, you know. So end user control is hampered in proprietary and enclosed ecosystems. And yeah, and we can see here 71% of the market was dominated by Google. So what we are seeing here is that the market is extremely concentrated. And so if we are talking about open internet, if we are talking about the future of connectivity, we should tackle the issue of software freedom over devices. Because devices ecosystems are mostly proprietary, as I just showed to you. Content and service providers compete for consumers' attention in unfair, discriminatory, non-transparent way. Because, well, this is how these closed ecosystems, they work, right? And internet gatekeepers, due to their monopolistic power over termination bottlenecks, control key aspects of devices, such as we showed, operating systems, browsers, app stores. So these are the problems that we are facing here. But remember the questions I made to you that perhaps if we talk about open internet and transparent ways, we need to talk about control over devices. And I would like to introduce an answer to that question. I would like to introduce you to a concept to think with me if we could find a solution for this. This is our humble contribution to this debate, and we think that perhaps would be possible to regain control, end-user control over devices, to regain our democratic control over devices in order to safeguard that rights that we were talking about some minutes ago. And I would like to talk with you about the concept of the device neutrality. Device neutrality would translate into software freedom in device. We don't want our device to be locked by determined vendors, so no lock-in, and we demand end-user control over data. These are fundamental principles that if we want to reestablish end-user control of our devices, the devices that we need to exercise our digital citizenship. Yeah, and what about the future? Yeah, fine. We have this concept. We have an answer to that question. But what about the future? Personally, how I see the future of open internet and devices. By the Free Software Foundation Europe, we have worked on several fronts in several areas in order to make sure that users can install and uninstall their software on their devices. For example, we conducted the router freedom activity that is concentrated on routers, that is the access devices for internet. But there are several layers and complex elements to tackle, and this is not very simple. And I would like to first, because I have a legal background, I would like to say that there are some challenges on the telecom sector. For an example, we see that devices being used in fiber connections, in satellite connections, on other type of connections, they are being proprietary. And, and therefore, when we start analyzing this, we need to understand what are the competition and internet law, nuances over that. There's also a very important component when we talk about sustainability of devices. For an example, right to repair, standardization, reusability of software. So these are more or less connected, although it requires different, solutions for that, but they are more or less connected to the concept of device neutrality when we want to disentrench these companies over their monopolistic position over devices. Therefore, I would like to finish this presentation with a request for you in the audience, for you that watching us live online. Support our work. We'll have a lot of things to do in the coming future. We need to make sure that these laws that were passed some time ago must have a proper implementation and proper enforcement. These are not easy tasks, but we are counting with your support. Not only financial support, but in our website there are different ways to be engaged with our work. Therefore, with this note, I would like to finalize my presentation with some message of hope that we can change the landscape of the internet. We are not alone on this, and I count with your support and help. Thank you very much.
Thank you, Lucas, for your passionate plaidoyer for this very important mission. Are there any questions? Yeah.
The microphone is, okay.
Here, come in the microphone, please.
Thank you. I have a simple comment. We need to act also on seemingly small details, like the EU has come out with legislation about the two-factor authentication. Unfortunately, all the implementations are smartphone-based. There is no way out. The bank, different services, you know how it is. Either a QR code or we send you an OTP and you have to find it. Because the software behind that is just a simple OTP generator, it would be sufficient for the EU to write in the directive, article so-and-so, The code for the generator must be free. The user must be able to get the key to that. In that case, we could realize, program it ourselves, and so on. Otherwise, we are obliged, we are compelled to use a smartphone and pay money to Google, to producers, and so on. And we can forget about digital sovereignty. Thank you.
Thank you for your comment.
Thank you for your comment. So the time is over. I asked one question. Short question, please.
Just a short. It's very important to understand that also if you would be able to technically open the data and open the software, it's not also important that the users open their hearts and their minds to use it. So there is you need also this factor too.
Good, thank you. Philosophical comment, thanks a lot.
Thank you for your comment. Thank you, Lucas, and all the best for your mission. We are with you. And so see you in 4 minutes for the last but not least presentation, where I promise you will see open hardware on the stage. So see you in 4 minutes. Welcome again to the Open Data and Open Hardware track of SFSCon. It's the last but not least contribution of this session, and welcome with me Roberto Innocenti, very famous face here at SFSCon, and he will present from design to reality the Open Hardware PowerPC notebook. Roberto.
Thank you. Okay. Power Progress Community is an association, no profit, and first I want to start before presenting the association that we have presented already a few times from 2018 year. But I want to thank what permit us to start our project related to the notebook Open Hardware, that is the free software itself. So without free software was not possible in any case, at least neither to think to do a notebook Open Hardware with a different architecture. So first I want to thank all the ecosystem. After that, I want to thank all the public events in which we had taken part in during the years, many times here in the Linux Day, FOSDEM, and other places, online or in person, and was the only possibility that we had and we have to share what we propose. So I want to thank that. It was me in the 2014. The first time that I present the dream to do these projects. And in the 2018, I was here for the first time to share the idea of the project, but I had in that time already schematics about. In the 2014 was only a dream. Already in 2018 was already a campaign of donation, a schematic, so it was already some step done. I want to thank Slimbook that built already a Linux notebook, because was the only option that we had to have a few pieces of notebook. I mean, body, all the body without the motherboard. So thanks to them, that was a collaboration, not in terms of commercial, because we are an association, so we doesn't do any commercial things directly, but only a question of common goal, common sensibility, common idea of free software. And so thanks to them, we was able to have 200, 300, we don't know exactly how much pieces we will do. I mean the factory that will do. So was the only option to use a chassis already existent. Thanks to NXP, that is the manufacturer that provided the GPU and that we select time ago, to give us the development kit that we had to transform in an Linux desktop, because this motherboard was our dev kit motherboard, but was not for desktop. So we thanks, because in this way we had already tested the PowerPC Debian. We thanks all the PowerPC distribution, I mean the distribution that even today support PowerPC, support PowerPC, Debian with the port and other distributions. So thanks to them it's possible to run Linux in this motherboard. And the timeline is the beginning, 2014. In 2016, we have established effectively the association. And after that, step by step, we have done different campaigns for the schematics, for the printed circuit board, for other simulation, for the 3 prototype, for the hardware tests, and so on. Now we are still in this campaign because we are finishing the extra cost that we have paid for the motherboard during the shortage period of chip. So it was very difficult to us because it costs very much each motherboard for the prototype. So now we are working with the paid person because we are a volunteer, but we have not the competence to do all this work. So thanks to the donation campaign, we have paid for the design. No? Now we are paying, thanks to the donor, for the U-boot video driver development and some few fixes about mechanical things issue for fit exactly in this chassis. I think I have already said that. Our goal, as association, is between open hardware and free software. We already work with school. I mean, we do a few in region Marche, in this place of Italy. We do in the school education or coding at the elementary school. So. Where you use all the laptop with Linux and so on. So this is not the only project, I mean the notebook project. So we do other projects, and we want, starting to this design that is already published from 1 year and a half, is not already completed, so you will see any newer update. But in any case, derived from this project, there are already a new schematic, more simple, and the idea is in the university stimulate, because other students start to make forks or new design more simple, and to create a culture of design hardware and produce even in little pieces to have something concrete for the students to measure and see the user what say and improve themselves. We are based on solidarity and free of choice. I mean, we think that it's very important that we need to fight against oppression, fight against what constrains us. So this is one of our DNA. We think that we need to create a social condition for equal opportunity, no? And so, in any case, we want to disseminate a conscious utilization related to the freedom of choice, related to different topics, and even to not become an information element for the surveillance capitalism that want only to use us like a resource to make money, no? Our goal, I have already said you. One more that I want only to say, because it's not that we already have in progress, but we want to do, is related to the science. I mean, we think it's very important to try to permit a situation in which different hypotheses can be openly shared, in which we can help the science and the technology to be far from monopoly and for only the interest of profit, but should be oriented by interest to improve the situation on the humanity. No? So it's another goal we at least have done less things about, but we will do. Okay, okay, so what means? People that join the association are motivated from passion, different passion, free software, open hardware, architecture, beginning, risk, and obstinacy are people that want to achieve each goal, even if it's difficult, or even if we need to think, to select, to choose. That people that have a rebellion in relation to closed source, in relation to what they doesn't like to live. No? So there is this kind of sensibility, I think. Few picture of few people around the world, few in Italy, other in other place. We was at the Linux Day recently, and I want only to synthesize between the 21 and 23, there was different issues to solve. During the July and June, we was inside the shortage of chips, so it was very difficult even to realize the prototype. And thanks to the donation, we have bought chip incredible cost, but was possible to do. We have difficulty even to find the same connector of HDMI, because what was not so freely available. Was difficult even to find again MD MXM, because we have a discrete video card that you can change and insert in an MXM connection. So there are a few issues that was practical. now we have, okay, it's okay. Now this year, after we have realized the prototype that was 1 year ago, we have 5 different difficult that usually probably other need to do. In this case, was more complex the chip, the GPU. So there was a little more activity to do, programming voltage, switching regulator, a FPGA that manage all the external peripheral. We have understand that one of the designer was not able to check exactly what happened in the board, but because at the beginning in May the board works but doesn't boot, doesn't arrive to the boot, so we have buy a JTAG debugger, find some people pay that can help in the firmware. So now we are finishing this stage before boot. No? We was for the second year an NXP day, meeting together between the people that design, that we pay for that, the person that will produce the notebook itself, because we doesn't produce, we are an association, no profit. Thanks to the ecosystem Open Power, we had the opportunity to share this project even in other contests, and as I have listened in other speech regarding the situation geopolitical, regarding many things interesting regarding open hardware, and I have seen that you have mentioned other opportunity over RISC-V, that is Open Power Foundation, where there is an open instruction set. So a new chip have this kind of open instruction set. Our not, because our is a chip from 2015, when we have started the design, and was at the moment the only one that fit good for a notebook. But in any case, there are FPGA, there is soft core that you can test this architecture, and there are 2 more little factory. These are fabless, but in any case that will make silicon not only soft core, but even silicon based on the open power architecture. So we hope in the near future some new design, more simple, will be possible to do with a more open architecture. The name of our power board is Teaching, that is related to the fortune. No? So we hope we have, we are lucky, we hope. And okay, I've already said. See, we have not already certified as open hardware, because before that we need to finish and test that it works. So see Debian Linux running and finish the process. This is an example of video card separated that is possible to insert. Okay, I have already said. So if you are someone that want to be a protagonist, probably in the near future there is a beta tester of the notebook, but will be done by another entity that is a factory, a cube system, so not ourselves. We have already done this, all these collecting money. We are in this stage, no? So we are near to the end, but could be that we have some more money because we needed to make a new version with some refix. No? I don't know if it's a note, but in any case, we are not a fixed. Step by step, we see if we need other campaign. And here there is JTAG debugger, the activity in which we are. Few change, removal of SATA track connector because of M2, and some change in mechanical. In any case, we are searching other people that want to be protagonists, want to make a good use of its energy life, because what we want to suggest and experience that change positively your life. It's not something that you do that is important itself. So people that want to make harmony with others, that want to open opens, because this exercise of dream is an exercise of possibility. Itself can be not success, I don't know, we don't know yet, no? Because someone must to buy the things, but is an exercise of open ops. That is very important. Okay, I think I can finish. If you have 30 seconds for the question, I'm here. Or
Thank you, Roberto. I have the microphone. Please hold it in the air, and we should take a picture, maybe of this nice piece of hardware. So you could show it to the audience. Are there any questions? Please.
Thank you. I wonder why didn't you use KiCad? Most likely because KiCad was not yet ready. And how does it compare with the Olimex project of the Teres open hardware laptop? And mainly, how do you keep up with the progress of technology, which is so impressive that a 10-year-old project is very difficult to maintain?
Okay. The first question, so I have last the first. KiCad. Okay, KiCad because we have not the knowledge to design directly. We pay for design. So the factory that designed, the designer, doesn't use KiCad. It's a 10 layer, so at the beginning, I think a few years ago was not already ready KiCad for that. The card is 10 layers. But in any case, we have exported with KiCad nightly version 1 year ago to KiCad the design. Could be that some things is lost, I don't know. In any case, thanks to the GitLab publishing, someone helped us to fix some issue in the design 1 year around. So before produce the prototype, there was already some fixing that arrived from people's side. We have selected PowerPC instead of other architecture because it was very a drop choice to not use anymore PowerPC in consumer. That was something political for our point of view. So for us, it's an exercise to demonstrate that it's possible to do. Obviously, it was a reason. And regarding the dynamics of technology, or in any case, the dynamics of creativity, in fact, we are pushing in some way the Open Power Foundation environment to give us the specification on the new CPU that are preparing. No? So, in any case, we are few, so we have a rhythm that is this. I hope I have answered everything.
Other questions? So there have been 2 long and intense days. Then I would say, first we thank to Roberta for your contribution. And then we come to the closing of this track and also of SFSCon 2023. Before closing, I would thank to all sponsors, to all organizers. Explicitly, I would like to name Emily and Luca and Lisa from NOI, who did nothing else than preparing the SFSCon the last weeks and months. I would like to thank all speakers. So many of you contributed with their talk, with their knowledge, with their passion, and also all participants. Without participants, this conference would not work, the physical, but also the online participants. Yeah, and with this, I would like to close this conference and already to invite you to the conference next year, which will take place on the 8th and 9th November, again here in Neutagberg. So thank you all. Have a good trip home and see you again next year. Bye-bye.